So my name is Wender. I'm a managing director of Advanced Potash Technologies, APT. So our company actually has Brazilian roots. It was a spin-off of another company, and we were always very strong in geology. What we started to realize in Brazil is that, well, being agriculture the backbone of our entire economy, is that farmers rely 100% on imported potash. So, and when we were attempting to try to solve this issue, and especially because the existing solution, so the existing product, which covers mostly 90% of the existing potassium market, is MOP, or muriate of potash, potassium chloride. It is a suboptimal product for many of our crops and soils, given we have a very poor and sandy soil, especially sandy soil in Brazil. What we then said is, well, is there any way that we can start producing potassium within Brazil itself to be able to provide that to our farmers? We really did a top-down approach. We looked at the earth crust and said, what other minerals, where else is there potash, or potassium rather, in the earth crust? There is a silicate mineral which holds 60% of all the potassium that exists in the earth crust. It's called feldspar, and this is the basic raw material for our product. Given our strong geologic background, we managed to identify several of these feldspar deposits in Brazil, and many of these located very close to agriculture areas, so ideally positioned in order to be able to transport then this product to the farmers with very simple logistics. The only thing that was really missing was a technology to transform that raw material, that raw feldspar, into a fertilizer. And why is that? If you look at the crystalline structure of feldspar, it's an aluminous silicate, so it's very stable, right? A very tight crystalline structure. If you mill down the feldspar, even if you do it to very fine grains, the crops and the roots of the plants will not be able to absorb that potassium. So what you then need to do is you need to have a technology, you need to have a method of disrupting that crystalline structure so that crops and roots are then able to absorb that. And when we realized that we required that, this is when we came over to the MIT, more specifically to the Material Science Department. The connection was established with the Eleanor Lab, where we sponsor research, and that team, with their expertise in material science, managed to come up with a low temperature, very effective hydrothermal process to transform feldspar into a high value add fertilizer. This is how the connection essentially was established and how we developed that. It took about a year for the first patent to be filed. We continued to develop the process over time to further increase our IP and also protection over the technology. And this is where we are at the moment. The project started roughly 2011. We started sponsoring research at the MIT in the year of 2012. And in about 2013, the first patent was already filed for. Okay, I'll tell you the story briefly. It was more of a, let's say, we met them at a conference, and the MIT personnel, with their expertise, but also desire to work on very important problems for the world, which can make a significant difference, they very quickly realized that this was a project which could have significant impact on people's lives and also make a very big positive change on a worldwide basis. And this is why very quickly, once we had presented our idea to certain professors of the material science department, that this is something they wanted to be involved in, we very quickly agreed on a research agreement where we then sponsored research with them and could develop and work to tackle this problem. We are trying to tackle the food problem. The most effective and impactful way of increasing crop yields is still through fertilizers, so nitrogen, phosphorus, and potassium. The first two, nitrogen and phosphorus, they are produced via very well-established industrial processes at scale and pretty much everywhere in the world, while potassium suffers from being highly geographically concentrated. and moreover, the existing product, so potassium chloride, is suboptimal for several of the crops and soil types that exist out there. Just to give you another background, 5 countries control circa 85% of the entire traded market of potash, meaning, and the top countries being Canada, Russia, Belarus, Germany, and Israel, right? These are all highly developed economies located in the Northern Hemisphere, while many of the countries which still suffer from very low yields and low quality soil types are located in the Southern Hemisphere. So you can already see there is a very big disconnection between where the fertilizer is produced and where it is also very much needed. Given the high logistic costs to bring that fertilizer from where it is produced to agricultural areas, especially in the Southern Hemisphere, that creates a situation where many of the farmers, which would actually require the product, are not able to acquire it just because it reaches them at a very expensive price. And that makes it then non-viable because he will not have the benefit of the fertilizer will not compensate the price that he's paying.